Okay, welcome back to math class, and welcome to part 2 of section 9-1. Yesterday we learned how to graph quadratic functions using a table. Today we're going to learn how to do it if we just have an equation. So first things first, remind you of your equation. It's going to look like this: all quadratic functions, ax squared plus bx plus c. Okay, now when you see an equation that looks like this, your c is always going to be your y-intercept. Hopefully you remember what a y-intercept is, but just in case you forgot, it's the place where your graph crosses over the y-axis. Another thing that we know just by looking at the equation, we can find the axis of symmetry . If you guys remember, when we graphed our parabolas, the axis of symmetry is the axis down the middle of it that you could fold both halves over and then be the same. The axis of symmetry with our equation is always going to be negative b over 2a. So negative whatever this value is divided by 2 times whatever this value is. That's going to give us x equals a number, and that number will be our axis of symmetry. To find our vertex, this point right here, we basically plug in whatever this x value is into our main equation to find our y coordinate. And so it'll look like, it'll be an x comma y, but it'll be the axis of symmetry comma y. So it'll basically be negative b over 2a y. And it'll be the y that we get when we plug this x value back into the main thing. I figure the best way to explain this is to just jump straight into an example. So over here, I'm going to give us an example. Y equals negative 3x squared plus 6x minus 5. Okay. Right off the bat, looking at this, I know that my y-intercept equals negative 5, because that's my c value. To find my axis of symmetry, that's when x equals negative b over 2a. So I'm going to put x equals negative b, and will be negative 6 over 2 times a, which is negative 3. So that's going to be negative 6 over 2 times negative 3, which is negative 6. Now negative 6 divided by negative 6 is just 1. So my axis of symmetry is when x equals 1. To find my vertex, I'm going to take my x value that I just found in my axis of symmetry and plug that back into my original equation. So I'm going to say when x equals 1, what does y equal? Y equals negative 3 times 1 squared plus 6 times 1 minus 5. So negative 3 times 1 squared is going to be negative 3 times 1. This is going to be negative 3 plus 6 times 1, which is 6, minus 5. Negative 3 plus 6 is going to give me 3. 3 minus 5 is going to give me negative 2. So y equals negative 2. Sorry, that's hard to read. Negative 2. All right, so my vertex is when x equals 1 and y equals negative 2. Those are my 3 things that I can find using my equation. One last thing that we can determine about this equation, about this function based on this equation, is what I told you yesterday about if a is greater than 1, then our graph is going to look like this, which means it's going to have a minimum. And if a is less than 1, our graph is going to look like this, which means it's going to have a maximum. We talked about that briefly yesterday. But the minimum and the maximum of these graphs is always also going to be the vertex. So when you find the vertex at 1, -2, now I have to decide whether or not 1, -2 is going to be the maximum value of this graph, or is it going to be the minimum value of this graph? To figure that out, I'm going to look over here at A, and A is -3, which means A is less than 1, which means the graph is going to look like this, and this point is going to be a maximum. So looking at this vertex, I can say our vertex is going to be 1, -2, and that is going to be the maximum value on this graph. One other thing we can do with this information now is find the domain and range of this equation. So hopefully you guys remember what domain and range are. The domain is all of the x values in the graph, and the range is all of the y values. Now, when we're graphing them and they look like this, or they look like this, these ends just keep going on forever and ever and ever in either direction. And we don't have any holes in our graph, so our x values, or our domain is going to be all real numbers. Oops. All real numbers. Because our x values are going to just keep going forever. Our y values are not all real numbers because, unlike with a linear function, it doesn't go in both directions on the y-axis forever. In this case, it looks like this when we graph it, right? We've got our maximum here. So basically, our graph is going to include all of the y values down here, but none of them up there, because it stops here. This is the maximum value that our graph goes to. So to find our range, what I know is that this will be the top value, this -2, and it'll include all of the y values below -2. So the way that I'm going to write that is that our domain is all real numbers, and our range is y is less than or equal to -2. Because it can equal -2, but -2 is the greatest value, the maximum value that our graph can possibly be. So our range includes -2, but it's all the other numbers that are less than -2.